Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed in building large-scale distributed systems.
I'm Adron Hall, and this is Jonathan Lacefield. We're going to talk to you about a few different things, but the first thing we were going to dive into is we were already kind of having a conversation, and I just wanted to kind of elaborate on what we were talking about earlier. So where were we on that?
Okay, first I just want to say you're a beautiful person. I really like your look. It's good. Yeah. Maybe lose the glasses.
The gleam. Yeah. Okay. Well, there we go. You know, different shot there.
Yeah. Okay. So we were talking about we're at a graph conference. I'm giving a talk later on something called supernodes and what those are. But the whole presentation on that. But we were talking about the adjacency lists and the root or what a supernode is a outcome or trade-off of using these things called adjacency lists, which are data structures that are optimized for graph processing.
Yeah.
And we're talking about like how nice of a fit that structure is to the Cassandra data model itself.
So how does that match work with the data model?
Yeah.
So you have these lists, but
yeah, and
it's two things.
And this is what the folks that originally built a graph database named Titan. They discussed, I think it was 2013, 2012?
A different eon.
Yeah, but they're the team behind DSC Graph.
Yeah.
And it's the kind of one of the foundational ideas is an adjacency list really just stores the relationships around a central vertex.
Gotcha.
And why that's cool is that with one lookup, I can walk out a graph from a certain vertex. Well, if you think about that, that is the same model as a Cassandra partition.
Okay.
I have a partition key, which would be my originating vertex,
right.
And all the relationships are just stored in a very flexible model, allows me to go out and continue to add there. So that intersection is literally projecting a graph model onto a Cassandra database, is really taking the concept of an adjacency list and storing it in Cassandra's wide row format.
Cool, okay. So that's a change? That's pseudo recent?
Well, so this is the foundation of DSC Graph, which we first introduced inside of DataStax Enterprise in the 5.0 version.
Okay.
Which we continue to build upon and improve upon. 6.0 was just out. We're looking at our next release on the horizon. We're going to call it 6.7.
Which is soonish.
Soonish, that's right.
Yeah.
I'm in product management, so I'm never going to give you a date. That was fair.
Being in engineering, dates are evil, so it's going to be here when it's going to be here.
Right. Yeah. No, it's not that far off though. And as you look at this concept of what taking a graph model and putting it on top of a Cassandra table, and you look at the full context of DataStax Enterprise, what we get into is really the multi-model story, built for a hybrid cloud,
right?
And all that comes with that, and that's a very broad discussion, but. Not from a change perspective, but from a looking forward perspective, having data that I can access through CQL or Gremlin, because it's stored all in the same kind of way, is very, very nice.
Yeah, definitely. It takes a lot of load off of not just the app development, but the operational side of things too, which is great. This leads me to one of my other thoughts. It's been bubbling around a lot in conversations today. And I've been wanting to ask you, which is, I've been talking with people about freight shipping, tracking things, nodes being like containers or whatnot. And just kind of fumbling into even the different word usage sometimes collides a lot, like containers, for instance. But what I was curious about is, what are the domains that you see using graph a lot these days? And especially, like, what's your own personal curiosity? Like, what would you like to see from different domains out there? Like, I'm a freight shipping nut. I love tracking shipping and trains and planes and all that stuff and seeing where things go. So I'm just curious, like, what do you like to kind of dig into and look at?
Sure. So for some context here, my view of the world these days is that there are graph problems.
Yeah.
And then there's graph databases.
Yeah.
Graph problems are bigger. To really solve them, you need more than just a graph database.
Oh yeah.
So the logistics use case is certainly one, and the graph problems really center around wanting to analyze and process the relationships between entities.
Right.
And really a lot of it comes down to what you're hitting on are the paths. Like
right.
How do I go from this to this? Another is like so some of the popular use cases that we see are customer centric.
Mm-hmm.
Like an enterprise would want a single, this has always been the panacea for enterprises, but give me a true single view.
Yeah.
The customer, but graph technology, it's truly a graph problem, and graph technology helps enable that.
Mm-hmm.
And by doing so, you can also see who are your influencers.
Right.
So it's not just paths, but it's connectivity. It's the connected components, to use a formal graph term.
Mm-hmm. Who
are the most highly connected customers I have?
Right.
Right, and am I looking at the folks that shop with us the most, or that require the most help and support?
Oh, yeah.
Or are they
like where that trade-off is? Yeah.
Right, and then you start overlaying like some social, are they influencing other buyers there as well?
Okay, yeah.
So one use case we see a lot is this customer 360.
Yeah.
And different permutations of that. Another is logistics and path finding, fleet management, shipping.
Oh yeah.
I haven't spoken to any train companies yet, but like more full carrier type customers that are very large. And then also, it's a little analogous to the customer, but the product side of things. It actually brings both of these together. So give me a product catalog. Inventory can be a part of that. Supply chain can be a part of that, because that is a very graphy, supply chain itself. If this supplier goes down, what are my other options? Right. That's a path problem.
Yeah, definitely. And that leads to one of the other conversations, which I found interesting, and this brought the conversation via Twitter about, you got all these planes flying different places with people going different places. And then all of a sudden, every once in a while, you'll see, wow, that's a really dirt cheap fare. And what it boils down to, like when you look at it tactically, is an airline has flown a bunch of planes into a place, and they've gotten people there.
Right.
Now they need those planes back out somewhere, and they have too many in a place.
Yeah.
So they're just they want to make it cheaper to relocate the physical plane from point A to point B, so they sell the dirt cheap fares. Even though they'll lose money, it puts some people on the plane to help cover the cost of getting it back out to wherever. And the conversation just came up as like, how do you map that out? How do you start to figure out where they've had too many flights go in, so now they need to get some of the planes relocated back out to where they need to be for the higher dollar, higher demand flights back into somewhere else. So that's one of the things I keep looking at.
Yeah.
Because I find it very curious, and I find myself manually solving the problem, which is time consuming. I know how to find the fares, but it's because I know, I'm an airplane nerd, so I know where they put airplanes. I know what kind of airplanes they're flying. I know what airports are hubs and things like that. But then I step back and go, oh wait, this is a pretty cool graph problem to try to figure out.
It really is. It's optimization and it's path. That's what it comes down to, and there's a lot of different techniques to do that. Mm-hmm. But yeah, that's essentially, what is my most efficient way to go from point A to point B?
Yeah. And
to overlay that on a full graph or a big subsection of your graph, subgraph as well. Absolutely. Yep. And we have we have folks in the airline and folks in logistics and fleet management as well, solving those problems today with DSE.
Yeah.
And it's interesting, and I mentioned DSE and not just DSE Graph, because Graph is a part of that.
Right.
But you need heavy analytics capabilities there as well, and a lot of times, a lot of search functionality to really make sense of the data.
And just like my own curiosity about the plane things, the first thing I started doing is, all right, well, I need to start collecting the data. So you don't just automatically put it in a graph like you just infer, You need to put it somewhere. So the database itself is the perfect place. You just start collecting it, and then you can start to figure out how to pull out the pieces you need and put it where you need, and then you can start graphing on it.
Right. What really gets interesting is the problems we, DSE Graph or DSE in general get involved with is, the kind of mode you're taking is more of kind of a static view.
Right.
But doing this based on live data. In a transactional system that maybe has a couple different workloads going on,
Right.
so that maybe your ticketing system is flowing through Cassandra component of
Right.
DSC, but then you also have this optimization that's running periodically based on that data,
Yeah.
automatically getting updates and seeing these things live. And it's really cool from a graph perspective. You can watch your graph mutate and change.
Oh yeah, yeah.
If you visualize this, you'll see, the more important nodes or vertices will become larger in your visualization and shrink down. And
Yeah.
you can see the paths as they move around as well as optimization kicks in.
Yeah, that'd be cool. And maybe at some point when I'm done, as a hobby collecting all that data, figuring out what I'm flying on, maybe I can get the audience to join me in putting together some stuff, and it might get real time. That'd be pretty awesome.
That would be sweet.
Yeah.
I'd love to see that.
Cool. So in just a little while, you're going to have a presentation, and we're going to record it, and you are going to be able to view this at a later time on the YouTube channel. So subscribe, go check it out. It'll be published real soon. So that's it for this Distributed Data Show. I'm Adron, and this is
Jonathan.
Cheers.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.